Soils are critically important for human life and also other life forms on Earth. They perform many different functions, so they filter and store water for us and for the environment in general. They provide a habitat for life forms, and of course this includes plants, animals, and bacteria. So plants and crops grow in soil. Critters like moles, snakes, prairie dogs, many other critters, earthworms live in the soil. And if you dig into soil, you will find millions to billions of bacteria for every gram of soil that you dig up. So if you have a tablespoon of soil, it has anywhere between 1,000,000 and 1,000,000,000 bacteria in that tablespoon of soil. And then also fungi is prevalent, especially in that very top layer of soil. So lots of stuff growing in that soil that you dig in the ground. Um, Soil is also important for cycling nutrients, and that's in our atmosphere and water systems. So it cycles carbon, cycles nitrogen, and also phosphorus, in addition to others. Soil is also important for many human systems. We need soil as the foundation for roadbeds and buildings. It is where where archaeological items are stored and preserved over time, and it's the source of a number of medicines. How does it act as a natural filter? Well, when water percolates through the soil column, it's important because uh, the water brings with it contaminants and chemicals, but these chemicals, for one, some of them just are too large to fit between soil pores. Some soil particles are very small, and the pore space between them is also very small, and so some chemicals are excluded just because of their size. Soils also have a reactive surface, and so they are able to absorb many potential groundwater contaminants. And so literally those contaminants and chemicals stick onto the surface of soils and are retained. Finally, there's microorganisms that live in the soils, and they live in those soil pores and stuck onto the sides of soil particles. And as chemical contaminants go past them, they extract them from the water that's percolating through, and they can transform those chemicals into different chemicals. They can biodegrade them all the way, or they can simply decompose them somewhat into other chemicals. So there's many different ways that soils are filtering water so that contaminants and chemicals don't make it down to the water table. Soils are also a plant and crop habitat. They provide many nutrients to plants. So these nutrients are in the soil column. They're coming out of minerals that are in the soil sediments. And this includes important nutrients like calcium, iron, magnesium, zinc, copper, and many more. It's estimated that 95% of our food is either directly or indirectly produced on our soils. So at first you might think 100% comes from our soils, but there are fish that we eat that aren't living in our soils, and seaweed, so that's not growing in a soil. But any crop and any animal that lives on Earth's surface are either directly or indirectly growing on or in the soils. This is an example of the soil food web. You may have seen this before somewhere else. So you can see here we have plants that are growing in the soil, and then they use the energy from the sun to take carbon and then carbon dioxide from the air, and they produce sugars that make up the plant material, and then that's the basis for all of these other life forms. As they decay, bacteria grow up as the bacteria munch on this decaying organic matter. Similarly for fungi, nematodes also feed off the roots of the plants, and then all of these other organisms are consumers that consume the plant material and then consume one another and grow up. As we said, the soil is critical as a way of cycling nutrients. So most of the plants grow up. Only 5% of the plant material that grows up on the surface is consumed directly by animals like this deer. The rest of it actually falls back to earth and is broken down on the soil surface. It's decomposed, so dead leaves and other branches, etc., are decomposed and they break down and become organic matter in the soil. And then this organic matter is taken back up by plants and used again. So the decomposers in the ground are cycling all of these, the nitrogen, phosphorus, carbon that comes out of that dead and decaying matter, and they cycle it and put it back into the atmosphere and or into plant matter. We said that the soil is critically important for preserving archaeological sites, because then sediments come down over time and get deposited on the top of old sites and old fossils, and then they get retained in that soil column and preserved. Also, soil is necessary for building sites. So when you're going to put a building onto a certain location, you want to make sure you have the right kind of soil there, that soil is stable and it has the right mix of components so that it's not going to sink whenever there's a lot of rainfall. You don't want them to build a building over the top of a cave, for example. Finally, many medicines have been isolated from soil systems. These include recent cancer drugs, also anti-diarrheal medicines and diaper creams are from soils, and many antibiotics are actually isolated from soil organisms. So if you think about it, there's a lot of organisms in the ground that need to fight off bacteria, just like we need to fight off bacteria that are invading our bodies. And that's because there's so many bacteria living in soil systems. We said there's between 1 million and 1 billion bacteria in any gram of soil. And so there's a lot of fungi and other bacteria that produce antibiotics they excrete these antibiotics from their cells into the surrounding soils, and then that provides a protection for them so that they can continue to grow and thrive, but these other bacteria cannot come in and take over their space. So that's why antibiotics are often isolated from soils. This is a picture of Dr. Selman Waxman. He was a professor of biochemistry and microbiology that he discovered more than 20 different antibiotics, and in 1952 he won the Nobel Prize for his discovery of antibiotics.